Tears in her eyes. Okay, so now that we have some of this information regarding radians, there's applications. And this is some of the application. As we talk about arc length and area of sectors, this is something you discussed back in geometry. Some of you don't remember really any of your geometry. I apologize for that. I wish it was different. I don't have time to give a full review of geometry. I could give you just a quick little brush up here. Arc length is referred to as S. And that is not the entire distance around the circle, but part of it. What is the entire distance around the circle called? And that formula is 2 pi r, right? And so 2 pi r would be the entire distance. We want a fraction of that distance. And so to show that fraction, we take whatever the angle is and divide it by 360, and that will give us that fraction then. So whether it's 3/4 of the distance around, or 2/10 or 1/5 of the way around, or whatever it might be. Now, this is if theta is in degrees. Well, sometimes working with degrees is more cumbersome. You get larger numbers. It's not as user-friendly. So let's work in radians. If you want to change this formula so you're working with radians, watch what I do. I'm going to move the pi up here along with the 2. Why can I do that? Because multiplication is commutative. All right? And as I write this, I'm going to write it as r times theta times pi over 180. Can everybody look at that and convince themselves that what I just wrote is the exact same expression as what's above? 2 over the 360 gives you 1 over 180. Theta, I just pulled that out front. The pi, I moved it to the top. It's all there. Same thing. Look at what I have. The 2 over the 360 gave me the 1 over 180. Does that look familiar? Theta times pi over 180? That's how you convert something from degrees to radians. So this is the conversion. So therefore, S is equal to just r times theta, given theta is in radians. That formula is a lot simpler than the original formula. What's the difference? You have to make sure you're working in radians. Let's do a couple of examples to bring this to light. Example 6 says find the angle in radians that satisfies the conditions. So I have a formula. S is equal to r theta. Radius of 7 and an arc length of 3, find theta. Find the angle, find theta. S is, what's S in this problem? 3. What's R? How do I find theta? How do I find theta? Divide by 7. So 3 over 7 is equal to theta. So 3/7 is your radian measurement. That's your angle. So that relationship is very easy to see. Next one, S, 13 is equal to R, 4 times theta. 13/4 is equal to theta. So that's the equation at work. Let's look at it in context of an actual circle. Find the length of an arc on a circle of radius 24. So I draw a circle. I'm going to label the radius 24. There is an arc. It says that the arc subtends. What does that mean? It means it intercepts an angle of 60 degrees. That's my shape. I want to find S, or the arc length. What is my new formula for arc length? S equals, it's a letter in the alphabet, R times theta. So S is, what is R? What is theta? No. Pi over 3. Why, Terry? You have to do it in radians. So I allowed you to make that mistake because that's a mistake that you'll make on the test. And I apologize for that. I will tell you ahead of time. I feel bad. Some of you will do that on the test. I don't want you to do that on the test, so I'm warning you now. Inevitably, somebody will do it on the test. Make sure that when you use this formula, you change this to radians. Pi over 3. If you're wondering how I got pi over 3 from 60, you haven't been paying attention really well in class the past few days. Okay, we practiced every day converting that to radians. We got pi over 3. Multiply, s is equal to 8 pi. Done. Don't you think that's an easier formula than your original one from geometry? You're indifferent. Very good. What's that? You don't remember it. Exactly. It's like geometry happened, forgot about it. It's like amnesia happens. Like every year you have a car accident, you hit your head, and you remember nothing. It's like, you know what I mean? Right? It's like, what happened to mathematics? So you block out things you don't like. Okay. You try to repress them. All right. Very good. All right. Let's flip back, and instead of talking about arc length, let's talk about area of the sector. K is the variable that refers to area of a sector, and the formula for area of a sector is pi r squared. That refers to area, but we don't want the area of the entire circle. We just want the angle divided by 360. Now again, this is if you're working in degrees. I don't want to work in degrees. I want to work in radians because radians are easier. They're nicer. So therefore, I'm going to change this a little bit. We'll see what you think. K is equal to 1/2 r squared theta times pi over 180. Can you convince yourself that those two expressions are the same? Okay. Does this look familiar? What is it? That's how we convert to degrees to radians. Thank you, Tristan. K is equal to 1/2 r squared theta, where theta is in radians. Easier formula. We like it when we make things easier. All right. Example 8. Find the area of a sector of a circle with radius 12, central angle of pi over 3. Radius 12, central angle, pi over 3. We want to know the area. My formula, which I will give to you on the test, K is 1/2 r squared theta. So the area is 1/2 times what is r? What is theta? We don't switch it. It's already in radians. So we leave it alone. Yeah? What's 12 squared? Divide by 2. 72 times pi over 3. 24 pi. That's your area. Now, if your worksheet asks for the exact answer, you leave it as 24 pi. If your worksheet says round it to the nearest hundredth, what do you think I would do? 24 times pi. Can somebody do that real quick and give me a decimal? Ready, set, go. It's your work time. I'm already done with mine. Okay, so nearest 10, 75.4. Okay, there you go. So exact answer, approximation to the nearest 10. Got the difference? Ready to practice this skill? And then we'll go on to our next piece. All right, so we're going to talk about two final topics. We're talking about angular speed. That looks like a W. It's an omega, the Greek letter for O, the long O sound. So the first letter of the alphabet in Greek is alpha. The last letter is omega. That'll be a lowercase omega. Looks like this would be alpha. This would be omega. Okay, that's what it looks like. There you go. Some people write like a W. So be it. All right. So I got theta divided by t. Let's talk about what that means. Angular speed. There's a couple ways to express angular speed. Most commonly, it's expressed as rotations per minute. So, for example, if you are operating a table saw, the blade on a table saw generally runs at about 3,450 rotations per minute. Okay. If you're running a router will often run at 15 to 25,000 rotations per minute. Okay, that's a lot, right? My daughter, 6 years old, learning to ride a bicycle. Okay, it's more like 5 rotations per minute. Well, probably more than that. But I'm saying like she's not moving as fast on the bicycle, right? Okay, so but we sometimes measure this in terms of the number of radians rotated per time. So a bicycle wheel is 24 inches diameter. Rotates 100 rotations per minute. Find the angular speed and the linear speed, and we're going to do the linear speed in meters per second and the angular speed in radians per second. So my formula for omega is to take theta and divide it by t. Now, theta is your angle. It's 100 rotations. What is 1 rotation in radians? 2 pi. Okay, so 2 pi is 1 rotation. How many rotations does it make? 100 rotations. I'm measuring in seconds. If it's 100 rotations per minute, how many seconds have gone by? 60 seconds. So I'm going to take 2 pi times 100 and divide it by 60. Someone, calculator, go. What do we get? No, why don't you put up here with the calculus one right here. 10.45 radians per second. We'll just go 4.5. There you go. It's 4.7? Okay, whatever. All right. That's all right. We forgive you. 10.47 radians per second. All right. Now it says find the linear speed. So let's just quantify this first. 10.47 radians per second. How much is 6.28 radians? That's once around, right? So this means every second it's going more than once around. Almost twice around, but not quite. All right, that's what that means. Linear speed is this. Velocity is equal to your distance divided by time. And S you may refer to as your arc length, or as I said, your distance, okay? And T is obviously time. Now the fact is, in order to calculate velocity, I would have to find the distance and divide it by time. Finding the distance is, kind of a pain in the butt. It really is. So I'm going to bypass that altogether. How does that sound? So now you got to just follow me for 1 minute to see how I use these two to come up with a better equation so we don't ever have to use that one. That sound good? Just try to follow along. Omega is equal to theta divided by t, and velocity is equal to s divided by t. You don't have to write this down, but you just got to follow along, okay? So I'm going to solve for t here. And if I do that, I get omega times t is equal to theta. So t is equal to theta divided by omega. Good with that? I'm going to take that, I'm going to put that right there. Therefore, velocity is equal to s over 1 divided by theta over omega. What do you do when you divide two fractions? Multiply by the? So I've got omega on top, I've got theta on bottom. Velocity is equal to s times omega over theta. So you're like, well, that didn't help me at all. I still got to find s. What is s? What did we just learn as a formula for s? S equals r times theta times omega. What happens to thetas? I get velocity is r omega. So that's the formula we want to use. Relationship, velocity is equal to the radius times omega, which is the angular speed. So velocity is, what is the radius? 12. What is omega? We already figured out, 10.47. Well, hi, buddy. What's 12 times 10.47? Somebody calculator, go. That's velocity, so we're measuring in distance. So what is our distance measured in here? Inches per second. 125.64 inches per second. Okay. One last example. Paddle wheel. Reminds me of prom. My first prom I went to, we were on a paddle boat. Went up and down Mississippi on a paddle boat. Had dinner and danced on the paddle boat. Pushed somebody off. No. All right. So it says the paddle wheel is radius 0.3. 0.3 meters. Rotates 80 rotations per minute. Find the speed of the current. So the current is going by and it's making the paddle wheel turn. So if we can find that velocity, that's going to be the speed of the water. We want to find it in meters per second. Well, velocity is equal to r omega. What is r? 0.3 times omega. That's what we have to find. We have to find omega right now. How do we find omega? It's equal to theta divided by t. Theta is your angle. What is one rotation? 2 pi. How many rotations? 80. What? In how many seconds? In 60 seconds. Somebody take 2 pi times 80 and divide by 60. 8.37. So velocity is equal to 0.3 times 8.37. If I do that, I get velocity is equal to 2.5 what? 5.1, and that's meters per second. So it's a fancy way of calculating that, and that's your other application. So what do you need to do to figure that out? You have a very, very short book assignment. So in addition to your worksheet, which some of you got 3/4 of that done, you have 3 word problems from your book. And those are intended to be short as well. And you've got a good 7 minutes to either finish up that worksheet or start that.